I'm live. It says I'm live. I'm alive. I'm alive. All right, gang. I'm excited about tonight. Oh, there's the camera. We've got a great night tonight. Skies out in June Lake, probably a lot like Manhattan Beach, are pristine tonight. The only problem we've got is a few contrails, jets dropping off stuff, and we're going to be going over this stuff in about 3 minutes, but I've got some problems over here, so stay with. All right, sorry about that. Back. Okay, so tonight, Night Lab. Lots to do, lots to see. We're really going to go over the Messier objects tonight, which is an interesting group of deep sky objects, and I do want to go over those and talk about why we are interested in those, as well as what's going on. It's heavy twilight right now, even though it's 8:15. Want to go over a lot of things. You need to get some stuff out, though. You need to get the map of the spring constellations that I put on Canvas, and I put it into the announcements. So you want to click on that, and you want to download that. Otherwise, you can't follow along. I will be getting Nina in a moment. She will be looking at you and looking at your chats. So we'll be getting that in a moment. And she'll be able to talk to you. But it looks like I'm really live, but right now it's still early. So we're waiting for a few minutes to get things going. Hope you're doing great. Tough time for all of us. And again, I think with tonight, we're going to get you to see some things differently, from dark skies to get beyond the Earth and feel what the universe and the beauty behind it. I'm kind of stalling right now because in 2 minutes we are live. 1 minute. So in 1 minute, I'm going for it. But right now, again, I can't check your chats. Nina will be doing that. Huh. All right. And I guess we're good. All right, Knees, we're waiting for you.
I'm coming.
All right, you're coming. I kind of went on early, and I think the volume's way too loud. So you're over there.
Yes.
You could plug in the headphones if you want. Do you see any live chats? Oh, just click on that window, I think.
This one.
So click on that window that I'm on there. Okay. Yeah, click on that. And that means you're going to YouTube when you do it, I believe. Because I don't see any chats. All right. Oh.
Hang on.
Okay. It should pop up. And tell me if you got chats over there, because that's the big thing. So why would the chats not be there?
Hang on.
Would they? We had them last time.
I know how to get them. There it is.
Okay, got them. Good. All right. So welcome, guys. I got notes, so don't make any mistakes. I don't want to make any mistakes for you. By the way, look, Nina, if you want to plug in the headphones right there, you could do that, and you could turn up the volume. You have to plug it in though and get that over there. So play with it, and then do yell at me. All right. So
wait, where's?
right side. Good. So you're about to see, what you're about to see is real. Be prepared to be amazed, astounded, unreal, unearth-like. Tonight, unlike the Pleiades night, going through a very slow process of going through the Pleiades, the Seven Sisters, where it wasn't much to see and we had a lot of goof-ups, tonight is fast-moving. All right, and again, you might have to do some other stuff later, like review this, which will be saved. So reminder, what you say and recorded is recorded and will be there for a long time. This is a night lab. Your ultimate goal is to do an 80-point project, 30 of which will be to document on a map where each of the Messier objects are. Now, we haven't talked to you about what they are yet, but that map is the spring constellations, and you folks have already done the spring constellation 2 of the quizzes, so you're ready for this. All right, the other 50 points is to actually capture the images that I'm going to get live, and to get those, and with those, you're going to collect them and put them in a photo album. And we'll do that by constellation. I'll give you more details on Canvas so you'll know exactly what you have to do, but you got to be prepared to capture the images on the computers. Now, if you don't know how to do that, I'll step you through it at the beginning, and if you have a Windows or Mac, I'll be with you. All right, now, we are going to be looking at some deep sky objects, not just stars. We're looking between the constellations, and we're going to be looking at what this famous comet hunter, in fact, his occupation, he was a French guy named Charles Messier, and his very close competitor, a guy named Pierre Machine, like the French accent. I think I'm working on it. But both of these guys were in the process of looking for comets. They got money for it. And as they were consistently looking for comets with their very poor optics of the day, they kept running into fuzzy objects that would confuse them. So Charles Messier decided to come up with a list to avoid, so he could do and find a whole bunch of comets. So that's pretty cool. Now, about 1784, he published his first list, and he had about 103 objects when it was finally completed, but in the 60s, 50s, and 1950s and 60s for us, they added up to 110 objects. So there's 110 objects, not to confuse against finding comets. Okay, good. Why do we care? Because these are some of the most outstanding deep sky objects located throughout the sky. Huh? Okay, I'll get to questions in a moment. That's good. Let me just get to this. So I'm just basically giving an overview of what they got to do. I haven't even talked about how they're getting their project yet. So we'll get to that.
They're just like, how do you check in?
What? Oh, you don't check in? You take your attendance like normal days. We don't check in like the old lab times, so don't worry about the check-ins. But let's keep going about Messier. So we've got 110 deep sky objects that we're going to look at. And we want to look at them from where they are, and it's getting dark outside. And we're going to look at them, and your job is to compile a list. But my director has told me that you have a bunch of questions, so let's go ahead and answer those questions.
Okay. First question.
Yeah.
From Jack.
Jack?
Jack Lewitt.
Oh, Jack L.
Okay, so it says, just checking, the quiz sheet for the second quiz was the same as the first quiz sheet.
Yes.
But we just had to do more constellations and do them in red for the second one.
Yes! Jack, you did good. Exactly the same quiz as the first three new constellations, which we included Ursa Major. This is in regards to the spring constellation quiz that you took on Monday. It included Canis, Venatici, Ursa Major, and Leo. While this one's the next one, you have to do it in red. We included Hydra, Crater, Corvus, and Virgo. So it was kind of a tougher group. So you got almost all of them. Now, don't get ahead of me and don't take the test because I got a brand new sheet for that. Okay, other questions?
And so, like, they don't have to check in on Canvas.
No checking in. You've already checked in. You'll just have to continue checking in. I know night labs in the old days would allow you to would grant you the ability to not attend class.
Okay.
But you don't have to check in. No, you have to check in normally during the day.
So real quick though, when you're doing this, I want you to stop every like 5 minutes.
Okay.
So that, because I don't want to cut you off. So I need you to turn to me periodically, so if there are questions, I could tell it to you rather than shouting them out when you're in the middle of a thought.
Okay, so what we'll do is stop every so often, but Nina, you know you're gonna have to yell at me.
Okay.
Okay.
I can't figure these out, by the way.
Okay, okay, but you'd only be hearing me anyway.
Yeah, but this is in the past.
Okay, it is always. Okay, let's get on. All right, now what do I expect you to do tonight? First of all, I want you to appreciate the night sky. I really want you to get what you're getting. You're seeing real life photos as we get to it. These are coming right off of great telescopes. In fact, as we look, I'll show you the two scopes that we will be attempting to use. There's the big one right now. It's pointed towards Regulus. Oh, and there's another one that we could have been looking at. Oh, not that one. Try to go forward. And of course, it never does the one you want to. And come on, behave. Oh, the other one's staled out. Well, this is the only one we care about, so we've got this one going, and that's good. So we will be using this. It's It's an observatory grade telescope. It's fantastic, and we'll be in good shape for that. So we'll be using that. I want you to, again, see the brightest deep sky objects. In astrophysics sense, we'll see them ordered throughout the sky. We're going to notice that certain of these deep sky objects are in certain areas of our galaxy and others aren't. So in a deep sense, I want you to see it. So we're going to understand the Milky Way. It's a great chance to see something. And by the way, we are with a remote observatory. That telescope is right now at 8,000 feet up, 7,800 feet. And it is beautifully dark and clear skies. So in a second, we're going to get going. You need two things. You need the ability to write where these objects are located with certain symbols. Again, all of this will be on Canvas later, but right now I want you to do it as we go along. And the second thing is you want to be able to clip the images as they come off, and so we can comprise them into a photo album. Okay, I'm going to go over, take a pause. So you need to get that map off of the announcements in Canvas. We're going, no questions. All right, folks, so how are we going to do this? Well, the first thing we're going to do is we are going to use this beautiful sheet of, well, it's a planetarium program, much like Sky Safari that you guys used before. And this will show you the constellations and locations, and we'll get to that. Right now, notice the yellow cursor is pointing over at Regulus, which is what we're going to be not starting with, but look at. The other thing we're going to do is that's called the SkyX, by the way, and that's going to help us where you're going to plot where the objects are. The next thing we're going to use is this. Now it's a little funky right now, and as I clean it up, I hope it gets better. Let's see if I can do this right now and make it a little bit better. And hopefully that's going to make it a little bit better. And we'll see if that does or doesn't. If it doesn't, I'm going to be very disappointed because it was great last night. And maybe that will help.
So, Slayer, Hydra.
Okay, we're not there yet. Okay, so we will be taking our images of, oh, I know why it's kind of funky. It's a little bit bright out there. From this area. So we'll take our live views, and some of these will be spectacular. It's black and white, but even though it's a color camera, you won't see color, not unless we stacked it. We'll get 15 to 30 second exposures, and pow, we're going to get and look at the different objects. So we'll use those. So back to what we got. This is where we'll get our images. This is where we'll find it in the sky. Back to this, you will make your first clip. And this is where we talk. Okay, we got more questions.
That's a real quick one. How does one do the extra credit if one doesn't have binoculars or a small telescope?
Great question. You don't have a small telescope, you don't get extra credit. Extra credit. You don't have binoculars, you don't get extra credit. You don't know the answer, you don't get extra credit. It can't possibly hurt your grade. It can help your grade. I want to encourage everybody to go out and use the stuff they've got. If you got a binocular, use that. It is purely extra credit, and you're not the only one who's not going to have workable stuff. I want to get people outside. Again, cannot hurt your grade. It just helps you, and it does what I want you to do.
And Jenna Wing asked, how many telescopes do you have?
Jenna, that's a big question. I probably have more telescopes than...
Children.
Well, I definitely have more telescopes than children. Then a good surfer has surfboards. Ooh.
That's a good one.
Yeah. I don't know how to else relate it, Jenna. Great question. I've got tons. Most expensive one is $7,000. The one we're using tonight is $3,000. It's riding on a $13,000 mount. My daughter didn't know that. When I went through my midlife crisis, I didn't buy a motorcycle. You know what I bought. Okay, any other questions? Because we want to go. We want to get these images.
Francesca asked, Mr. V,
Fred!
If it says I keep leaving and joining, it's because my Wi-Fi is whack and I keep having to refresh the page.
That's fine.
What are we looking at specifically for the extra credit?
Okay, let's go over the extra credit. You need two things. You need to mark down on a chart or a sky map. This is what it looks like. You download this. Hold on, we'll get it. There it is. I'll show you the big screen. So you download that. And, great question, Fran. You got to remind me, that's 2 extra points for that brilliant question. And ultimately in the evening, you will have come up and you will have done something like this. Do not stop the video later and copy this out. This has more than you need to do. We are going to plot the Messier objects throughout the sky. If it's a galaxy, we'll put an oval. If it's an open cluster, we'll put dots around a circle. If it's a planetary nebula, we'll put a circle with a plus on the outside. If it's a globular cluster, and we'll do this when we go on. But I will stop. You take your map, you put the spot of where it's located, and this is worth 30 points. Yours has the directions on it. It'll have it written up here. It has a name and it has a title. This is just an overview. All right, I like those questions. Great questions. I want to get going. We're going. All right, the first thing we're going to do is go to here, and we are going to the SkyX. In the SkyX, I know that all the winter sky constellations are setting. So they're going quick. I'm going to go over here and get the first one, which I want to come over in this area, move the telescope over there, and I'm going to go into the heart of Canis Major. Yes. And as I do it, the scope should move. And it might have to go the long way to do it. All right, so we're going around the world, all the way to Canis Major. And this is the first thing you're going to mark. Is it plugged in? You have to turn up the sound, Nina, so it sounds like
it's coming from the computer. It's not coming from here.
Oh, because you didn't plug it in. You got to plug it inside. Oh, okay. And right now, if it's right above the mountains, I hope, we're in the heart of the dog. This is M41. So if you had pulled out this thing, whoops, wrong one, go away. You're going to mark right here with little dots around it, M41. Now, let's go take a picture and see what it looks like right now. Fingers crossed. So I'm going to Sequence Generator Pro. I'm going to take an image of about 15 seconds because it's still bright over there. And it's going to be taking our first image. All right. Crossing fingers. Hope to go nuts. Now, this is what I could be talking about. Let me talk about a little bit. This M41 is one of the oldest, perhaps, known open clusters. So you need to write down open cluster. There it is. It doesn't look like much because it's this whole thing. It's huge, and let's get it back to frame. There it is. There it is. It's a sprinkling of stars. M41 on your computer. You're going to need, if you got a Windows, you're going to snip it. How do I do that? I type in the word snip. And let me see if I can show this to you. I type in the word snip. And I get this. This is if you have a Windows computer. And with snip, grab new, highlight the area, bingo, and on your photo album, you're going to need to write what it is. This is M. Now, I'm doing this quick. 41. You have to still tell me the type, galactic or open cluster. Got to give you the magnitude, and the magnitude of M41, I have it on my sheet because I don't memorize these things, is 4.5. And I'll stop after I do the first one because I probably have some questions for you. And in its distance, 2,300 light years. And you might look at that and go, well, that's not that pretty. Oh, yeah, it is. The ancients, Aristotle wrote about in 325 BC, and there's about 100 stars here. It's about 2,300 light years distance. It's over near our Orion arm. And it was called a mysterious cloudy spot in the heart of the dog. So you just got your first one. If you have a Mac computer, remember how we did this back in Kerbal Space Program? What we did was we did a Command Shift 3 or 4. One will give you the whole screen and the other one will snip it. So that's what you're going to do every time. I'll stop for a moment and see if you guys have questions.
Yeah.
I'm sure there are, but let's get back to the big screen. Okay, questions, Zena?
This is kind of difficult because it's lag, so I don't know what some of the questions are referring to.
Okay.
Like where do we put it?
Oh, right now you don't put it anywhere. You're gonna save these for later. Save them so that you can put them in a photo album for later. So do save each one.
So this is funny.
Good question.
So this is a two-part. Holden asks, "Are we supposed to be doing anything right now?" And Ian Kirby responds, "We don't have to do anything yet except pay attention."
Okay, well, yeah, well, you're going to have to rewatch. Holden, you're going to have to rewatch the video because we do have to take, well, number one, mark on a map where these Messier objects are. Number two, take a photo album picture that includes its name, its type, its brightness, and its distance. We can look at that later.
And then it was, when do we need to screenshot stuff?
Every time I get a new image of, you want to take an image of the actual picture. So the one over here in sequence generated approach shows M41. Let's keep going. Okay. We'll look and find out other ones.
So some of them are, we can't see your cursor, so we don't know where to mark. It's cut off.
Oh, what cursor?
I don't know.
I don't know either. I don't have a cursor.
Okay, someone asked, how do we get credit for this?
You're going to have to look at the, okay, if you have not tuned in at the right time, you're going to have to get credit for the project when it's due way next week. So we'll get that on campus. Follow directions. You might have to rewatch this again, but you will miss out on seeing everything live. Here, for instance, you're seeing this amazing shot of M41, and M41 is the 41th object of Messier's images.
So says, I don't think we can see where you put the dot. Can you show it again?
What dot?
It's hard to screenshot it since your little window of you is covering part of the stars.
Okay.
I can't take the screenshot because the image is hidden behind your face cam.
What?
Face cam is covering it. The image is behind your head.
No.
M41 was blocked by your face.
How could that be? I'm looking at it right now. I'm looking.
So, do you see this on my screen?
What about it?
Is this the same as what you're looking at?
Yeah, that's not blocking anything.
Okay.
No, the image. Let's look at the image again.
So M41 seems to be the question.
Okay, well, I'm just going over the first one.
And then the last question.
Let's do this again.
Oh, this was easy though. Do we need to write the magnitude and distance too?
Yes.
Okay.
You do. Magnitude and distance. All right. My face isn't blocking anything. This is the image. Let me show you the cursor. I hope you could see it. So, oh, that's what you're talking about. Mm-hmm. This is M41.
So I'm waiting because it's lagging, so I'm waiting to make
sure. I know.
Sure.
Well, I don't want to keep answering questions. We've only done one.
I'm waiting to make sure that what you see there is popping up.
It will never be.
There we go.
Okay. It will happen. So that's it. You should see it. All right. Next object, you'll get into the flow. If you don't, you're going to have to rewatch it again. Let's do what this is about. Let's look at the images. So we're going to go once again, and we're going to look at the next object a little bit further up. So in SkyX, I'm going to click on over to M47.
Oh, no. Where do we put M41 on our paper?
Save it. Clip it. Photograph it. Save it. Oh, M40. I've already done that. It was right here. I don't understand.
I don't know how far behind it's lagging, so I don't know.
Well, I know.
What's being spoken.
Wherever that yellow cursor is, that's where it's going to be.
What cursor?
You don't see a cursor there, the yellow thing? Oh, oh, I see. You guys want me to get a little closer. I can do that. All right. I get it. It's too far away. Technical difficulties. So much for the beauty of the universe, huh? All right. So much for our night lab. All right, next thing, we're going to go for M47. Yeah, I guess this isn't what I expected it to be. All right, we're going to go next to M47. Watch the cursor move. It should be closer. The yellow is where it's at. This is in the constellation of Puppis. We're going to now go over and take a picture. Yes. And in Sequence Generator Pro, I'm going to go over and take a picture. Yeah, just turn it up a little bit if you need to. All right, so 15 seconds. I'm taking a picture of this. M47 in the constellation of Puppis. Here's a 4.4 magnitude star cluster, open cluster again. Let's see if we can see the difference. And voila. Woo. Okay. So if you have a Apple computer, Command Shift 3, Command Shift 4, or if you have the snipping tool, you take out the snipping tool, and you hit a new one. I will grab the area, let it go, label it M47, and you need a few other things. It's another open cluster. Its brightness is 4.4. It means you can see with your bare naked eyes. Our limit's about 5 or 6. Its distance is 1,600 light years, so it's closer. And these stars they're about 50 stars. And because they're bigger, you could tell they're closer. So that's kind of neat. And then you go and push save. And there you go. So I'm going to get rid of this so you can do that clipping again. And there you go. So this is your chance to clip. So as you're clipping, I'll talk a little bit more about it. So again, it's about 15 light years apart. It's another open cluster. We're looking along the galactic plane or in our galaxy along the edge. And that's what it's kind of neat to look at. All right, take your picture. If not, you'll have to come back later, watch the video. Next place we're going to go, next Messier object, is called M46. I'll get a little closer. So M47 is right near to the left of the head of Canis Major. And to the left of that is M46. So it shouldn't take long to get to M46. And let's see live what this object is doing. And it takes a little bit to do this. So M47 was the one that had coarse stuff. So moving, there we go. So now I want to go and take another picture. You guys will get the flow. So the first screen on the planetarium program, you want to actually annotate a little spot with little dots around it. Right now, just label it M46 for this next one. Now I need to go and take a picture. 15 seconds. And I'm waiting. Now, M46 is kind of neat because this one is twice as far as the first one. So M41 in the Canis Major, this one is 4,900 light years. Its brightness is about 6th magnitude. And look at that. Oh my gosh, look at this. Okay, so what are we seeing? We're sailing 500 stars. This is your chance to clip. 500 stars. And if you look closely, you'll see something weird about this. So it's fainter. That's gorgeous. Look at this. So out there in the constellation, right off Canis Major in Puppis, you didn't learn this, is this beautiful open cluster. A galactic cluster, and right in it, that little smoke ring. Whew. That's a planetary nebula. That's where a star has gone out, blown up, as you learned in the life cycles. It has gone out and left the remains. After it burned helium, it coughed up a ring. Now, some people say that this planetary nebula, number NGC 2438, is actually not inside it, a little bit beyond it, but hey, it looks pretty coincidental. It's an old one. It's 100 million years old. Most planetary nebulas don't last more than 10, 20, 30,000. And we're going to stop in a moment to answer more questions. But beautiful as you see it. And I would snip that. Crazy good. And what do we got here? All right, it's kind of speckled, but... All right, Nina, what do we got?
All right, so I'm just making sure.
Yeah.
So apart from writing our paper, labeling where the clusters are, we also need to take screenshots of everything and make a slideshow with the magnitude and distance.
Okay, let's clear it up again. I got it. We're getting it down there. The first thing you need this chart, and it's going to be done for only the things that we've seen. You download this. We put M41 here. M47 about here, and M46 here. We've gone, and all three of these along our galaxy are these open clusters. Interesting. Talk about open clusters in a moment. That's for 30 points. By the time of the evening, you will have labeled all the constellations. You'll place a symbol and the M number. That's it. And if you have to watch the video again, there it is. It doesn't look like the video, but it should be. Also put your name on it. So this is 30 points. The other thing is a photo album that you'll be grabbing, taking pictures, and every photo album needs to have... did I not show that? I don't think it showed up. I think I had the wrong screen. Let's do it again.
Yeah, I was going to say.
Okay, so the screen did show up. Let's try it again. All right. So here we go. This is the screen. M41 here. I apologize, guys. You guys, I'm not used to teaching. You're not used to me teaching. And it's a lot easier if you're all with me and we can do this. But here I just got Nina and I, and she's reading. And I'm going, God, I just want to show you these things. They're so beautiful. But we got M41 here, M46, M47 about in these two positions. You're basically labeling where they are. You read what it says, label the constellations, put the Messier numbers down there, and put your name. And by the end of the evening, you'll have only the ones that we cover. So ultimately, you'll have something that looks like this, but it won't be this bad. We're not going to, there's a lot more objects here than we're going to go over. We're just going over the highlights. All right.
Okay.
So two things. So
Caroline Vogel says it's blocked. This is some time ago, but she says it's blocked because on live, we can see your window, which covers part of the image that you want us to get.
Okay, so I need to get rid of my image.
Or can you make it smaller?
I can. I think it has to do with the screen you're on. Yeah. Okay, we're going to make me really small and the telescope really small.
All right. I'm going to go down a list. What is the magnitude and distance of M46?
All right. Magnitude of M46 was 6.0, and the distance was about 5,000 light years. 49,000 is the amount. But I'm trying to make these screens smaller. SkyX has been blocking, I guess. I think it probably changes with the size of the screen, so I apologize. I kept saying, yeah, I'm not blocking anything. How could it be? So I made those real small. I think I'm good there. You don't need to, if it's blocking me, who cares? So that, maybe this.
Hang on. Move it to the top right.
Well, then I'm blocking stuff up there too. It just doesn't matter. I'm making them real small. So I'll have these little midget pictures. All right. Okay. Next object. We're moving. And we'll stop for more questions. You guys, no problem with the questions. Again, I'm not used to this, and you guys aren't either. All right. So next object, remember, we're going to go to a new spot. Here's the SkyX. Hopefully everybody can see now. And I'm going to look what else we could do. So we were getting real low in the sky, right above the mountains. I want to go up to Auriga, the charioteer. Here we've got three open clusters, M38, M36, and M37. Let's go up in this area. We'll start with 38 and see what those are. What are those? All right. So with it, M38, I'm going to say, go telescope, go. And as it goes, I'll get you closer. And where you're going to put it, we'll put a spot right in Auriga, right there. Okay, I'm going to center on it so you can see it a little bit better. And I'll get closer so you can see it there. I think, yeah, some of you guys probably have different laptops and such. All right, let's get it centered. And that should be better. So, M38, what is it? Here's the charioteer, his capella. We've learned that. There's some interesting stuff, but it's probably gone. I want to now go and take a picture. We're over here to take a picture. Remember this last one of M46? It had that planetary nebula embedded in it. That's glorious. You guys, this is out there right now. This is observatory class stuff. All right, let's go for it. Going to take a 15-second exposure. And M38, it's also called the starfish cluster. Its magnitude is 6.4. Its distance is about 4,600 light years. I don't know why it's called the starfish. There it is. Let's get it the full view. Look at that. The starfish here. It's got another open cluster, another galactic cluster. What are we doing? What is Messier doing? He's seeing all these galactic clusters back in the day. It's 25 light years in diameter. That's how long it is. It's about 220 million years old. Interesting. We'll talk about ages and another open cluster. So this is M38. Let's go to another constellation, not constellation, another Messier object real quick. So let's go get closer here. We said we want to go to M36, so we want to go here. So, you guys, on your charts, I think you're getting the flow of it, or you've just plain given up. That could very well be too. Sorry about that, folks. But we'll get good, cool stuff in a moment. So right now you're going, oh, I'm spinning. What am I supposed to be doing? Look, it's going to get better. We're just going where we're losing the winter stuff. So M36, let's move over to it. There we go. Plot this, write this down. You don't need to take a snip. And maybe I should have stopped you for the snip. And you'll have to go back if we miss it. But here we go. We're going to go Sequence Generator Pro. Oh, I didn't show it. Here's where we're at. Okay. Maybe I've asked you to do too much because I'm getting a little lost too. So there's the location of M38. Now we're on 36. So I'm going to ask it to take a 15-second snapshot of it. We'll go over there. Remember, this is 38, the 38 object that Messier found. And presto changeo, live feed, there's 36. That doesn't look much better or much different. By the way, I think I can go back. Yeah, you guys, so I think I can go back. If you need, not too far, but if I need to go back a little bit, I think I can go back like one spot. So this one, no, it's not letting me go back. Okay, well, I thought it would, but it's not. Anyway, so here's M36. M36 is about the same distance as M38. It's another open cluster, magnitude 6. Distance is 4,600 light years, the same as M38. So this is 36. This is also known as the pinwheel cluster. Pinwheel. I want to get one more and then we'll answer questions. So you guys have questions? I'm going to get one more done. So you take your snip on this, you do Command Shift 3 or Command Shift 4 for you Mac people. And again, snip it and save it. Snip it and save it. You'll label it later. It will take nothing for you to grab it and just put them in order. What constellation we're in? Auriga. All right. So there's 38, 36. These are Messier's objects. He thought they were comets, or he didn't want to get confused as comets. And let's go to one more before we got questions. I now want to go back to the Sky X. I now want to go and get M37. It should be located a little bit lower. And it's going to move right to there. This is the next spot you put on your sky chart. And a word on sky chart. Remember this? Here's what you're recording on your sky chart. You're putting 37, so 38, 36, 37. They are there for you. There's the hat. And we're in Auriga. So we're still in that galactic arm. And we will take a breather in a little bit, but I want to get to a spot where we can actually get to the more impressive things. Although these are pretty darn good too. All right, so let's let it take a 15-second exposure as we go back to here. It's going to take a 15, so you can see it running to the right. The green line as it fills up does indeed fill it up. And voila. Boom. Oh, there she is. Oh, wow. That's beautiful. That's more impressive. Magnitude 5.6. Looks like M37 is another open cluster. We have done nothing. M41, 46, 47, 38, 36, and 37. And they're all open clusters. This is brighter. You barely see this with your naked eye. It's magnitude 5.6. and its distance is about the same as the other two, about 4,500 light years. It is 500 stars. There was only 60 stars in 36, and there was a bunch more in 38. But what's neat about this is if this was where the Pleiades is, if the Pleiades was the same spot as this, if we move this one where the Pleiades are 400 light years instead of 4,500 light years, if it was 10 times closer, this thing would easily outshine the Pleiades. That's beautiful. All right, I'm going to take a break and answer some more questions.
Starting all the way from the top.
I know. You got to wait for every little bit.
Sophia Strauss asks, do we need to turn anything in from this live tonight?
No, nothing turning tonight.
Okay. And give me a second. And then Jack L asks.
Jack, you're back.
For the size and distance, am I supposed to be annotating that information onto the screenshots as we go?
No. I would write your pencil down real quick as you do this. And if you want, once I get through all of, the next 3 objects, I will stop it there, boom, and rehash and give all the answers again. So I'll give those answers again for those. But the only things you need for that is the name, the number, the name. You don't need the starfish nebula. Those are, they've come over the years and people name it, hey, that looks like a pinwheel. And wait till we see some galaxies tonight. But you need the name, you need the magnitude, you need the distance. That's it. 3 things. Name, magnitude, and distance. Well, type too. But eventually they're all going to be a certain type.
So Auriga is not on our paper. And it says, Bart, what do we do? Auriga is cut off from the paper.
No. Who just said that?
So I have...
Who said that? I want to know who said that.
Okay, sorry, Camden. Auriga...
Camden. I'm going to look right now.
Dimitri, Auriga's not on there.
Well,
Victoria, Bart, what do we do?
Whoa. I'm looking at the paper I gave you. Looking at it. Here it is. This is the one that you should have printed today under announcements. Camden, you need to learn Auriga right here. There it is, Auriga. You forgot the hat. There's the nose. It's just drawn a little differently. Everyone's a little bit different. Even Leo, I don't like the way Leo draw.
Okay, I'm waiting for that to show up on here because I still haven't seen it. Okay, there it is.
Yeah.
All right. What's the magnitude and distance for M41?
We're going to review all that.
Okay, and hang on, I'm still going. And then what's the magnitude for M46?
We're going to review all that.
Okay, hang on. Let me keep going. So just so I can finish this little group. So Kendall, Auriga it's right above Gemini.
Yeah, we got that. Yeah. All right, moving on. And then we'll do a giant review.
You're good. You can
Excuse me, guys.
Can I
Okay.
have some Mountain Dew?
Sure. Mountain Dew, Yahoo. Okay, so where are we going? Let's take a look at the whole sky before we move on and kind of analyze what we've done. So because it's all setting, I wanted you to get the feel and structure of our galaxy. We kind of went from down here to here, and we want to cover in here, go through Gemini and Cancer. We've looked at 41, 47, 46, 38, 36, 37, and I want to get 35 right here. Let's get a little bit closer. Whoa. Well, that would be a little too close. Want to get to M35 right here. And with that, M35 in Gemini is absolutely outstanding. So let's get a little closer to it. It's moving. A little closer so you can see. So off to the right, twins, Messier found another object. So I will go ahead and start taking my pictures and start talking about this. So you're recording this in a moment, and we'll do a quick review after 3. A quick review. All right. And let's find out what we've got. So, oh, look at this. Look at this one. Are we all the way out? Okay, got it for a minute. Look at this. So, this is M35. M35 is off Castor, the right foot. And you can see here that we got 2 groups. Kind of look like 38 a little bit. Look at this one and this one. Both these open clusters are the same distance, so they're open clusters. This one is M35 majestic, And this one is a bizarre number. You don't really need it, but I want to give it to you anyway because that's just what we do. It's MGC 2158. Again, located the same distance, but this one is quite a bit more outstanding. There's 500 stars. It's beautiful, obviously. It's about 100 million years old. And it's about 1,600. Oh, this one's 3,000 light years. Boy, did I make a mistake here. They are not the same distance. I'm thinking about something else later. This one is 3,000 light years. This M35, which you are now snipping or copying. And this one here is 16,500 light years away. That's the difference. You can see that this is real life in our telescope. We're seeing how beautiful this is. Magnitude 5, and I don't know, in Gemini, gorgeous. Okay, why all this talk about open clusters? Let me just do a quick talk about open clusters. Okay, open clusters, another name for them is galactic clusters. We've seen them located all through the galaxy because that's where they're located. They are star birthing areas, and they're formed generally what astrophysicists think as a cloud of cold gas goes through a spiral arm. It forms stars, just like we were born. These things aren't very big. They're erratic in shape. They're open. There's about 20,000 different ones. No wonder the ones we've seen so far haven't been that spectacular. Well, I think they have been, but they haven't been amazing, but they're in different shapes and different sizes. They don't last very long, generally on the order of millions of years before they're spread out through the galaxy. And there are exceptions, obviously. I just keep thinking they get formed when they go through the spiral galaxy, and that's kind of neat. So there's a lot of them, and they're only in the plane of the galaxy generally. Okay, 2 more, and then we'll do a rehash because I got to get through this. Next part we want to go up through is into Cancer. So those people born under Cancer, we are going to M45, which gives anybody an opportunity for extra credit. I mentioned this. People don't have binoculars. I get it. People don't have telescopes. I get it. It's like who answers the question first? I give extra credit. So we're going to go to M44. I'll bet you know what this is going to be. So we're going to mark this down. Remember, 2 more, and then we'll do a review.
Credit?
The up and coming is extra credit.
Okay.
Yeah. I don't know why is this. Okay, here we go. So we're going to move over to M44 in Cancer. Take a look. All right, we're going to start our pictures, and I'm going to show you the Beehive. Now, the Beehive is going to give you extra credit. And here we go. It's going to get 15 seconds worth. And it's one of the oldest and most famous of all the clusters. Another name for it is called Praespy, or the Manager. Okay, and you look at it and you go, that doesn't look like much. This is zoomed all the way out. Well, there it is. This one was noted by the ancients. It was called the Little Mist. The Chinese have a name for it, and I really wish I could pronounce it, but let me translate it instead. You know, in class I'd probably imitate it, but I'd probably get in trouble for it here. But it's called the Cloud of Pollen Blown from the Willow. So here it is, 1,000 stars. One of the closest open clusters we've got. Magnitude 3, you can see with your naked eye. 600 light years away. It is likened to the Hyades in Taurus. And that's right where Aldebaran is. So it is going in the same direction. It is probably affiliated, and we're kind of between them. 600 light years away, same motion as the Hyades. That's nuts. M44. All right, extra credit. Here's what you got to do. Let's give you 2 nights to do it. Tonight and tomorrow night. Point your binoculars over. And I'll zoom up on it right here. Closer. Right in between Castor and Pollux and Regulus. In the middle, point your binoculars. take a 5 to 15-second video of you using binoculars or a telescope. And for those people who do not have those who would like to get extra credit, go out there and show yourself looking for it with your naked eye. I'll give you varying amounts of points, 3 extra points for naked eye, 4 extra points for binoculars, 5 extra points for a telescope. If you got one, nobody's got telescopes, maybe 1 or 2 of you. And then you guys, with that, tell me your name and tell me what you see. And if you want to actually let me use your video clip later, leave it be. If you don't want me to use it, put down, please do not use it, so that we can keep it private for you. So there it is. We almost get to the review point, and we'll stop, and I'll answer some questions. The last one I want to get to is right here, M67. It's the last before we can get really exciting. Notice we're starting to deviate away from the galaxy, the edge of the galaxy itself. We're starting to look through the side of the galaxy. Pretty neat. A-okay. Let's look for M67. And the computer will let it move. And it does. A little bit off because it's actually designed for another telescope. I am now going to take 15 seconds. And the last Messier object we're looking at that keeps all in the same thing is, to me, one of the most exciting ones. We'll go ahead and show you a picture of this right now. And voila. Get ready to snip this. It's downloading the image. And there it is. Wow. Okay. Looks like an airplane traveled right through the field. This one's M67. Why do I like this? It's probably one of the oldest clusters ever out there. It's so old, it's about 4 billion years old. It has drifted outside of the plane of the galaxy, and most open clusters don't last but a couple 100 million years, but this has already been 4 billion years, almost as old as the sun itself. There's 500 stars here, and it's probably going to last another 5 years. 5 billion years for sure. All right, you guys, snip this. Let me answer questions. They're dying.
No. There's not really any questions right now.
No questions. All right.
You already answered the M.
Okay.
The M41.
Let's do a quick review. Maps, guys. So, we'll take out our map. And there it is, the maps. You're going to drink all the stuff that I need.
I'm really thirsty.
Well, I'm talking. M41. Let's give you numbers. So M41 on your chart. Down here is our first one. It's an open cluster. Magnitude 4.5. Anything below 6 could be potentially seen with your eyes if it's dark skies. Distance 2,300 light years. M47. That was the snippet you got of bigger stars. It's open cluster. They're all open clusters. All of them so far is open clusters. The good stuff are in a moment. That's why I paused now. All right, you guys. Magnitude 4.4. M47, 1,600 light years. Okay, we went to M46. This is the one with that little planetary nebula. A star had died, left that little puffy gas nebula that they don't last that long, but this one's supposed to be quite old. M46, open cluster, magnitude 6, and it's 4,900 light years. It was fainter, it was further, you could tell.
The right side of the chart is cut off.
Oh, that's what they're saying?
Yeah.
All right, I'll make it smaller.
And then can you
There.
move your face to this side?
There's nothing there.
Like, because there's nothing here.
Oh, okay. Yes. My daughter has told me to do this. She's smart. You don't need me any there anyway, but okay. So where were we? We were here. All right. It's smaller. Go on.
Can you move it to the left-hand side? You can't do
Hey,
that?
stop. Wait. Yeah, we're doing it. Yeah. So we did it. It'll be there. You just remember, they've already, they're there. Now I move over. So, oh, so it needs to be higher? I got it.
Okay, so I got you moving. Okay. Look at this. It keeps going into eternity.
Yeah, I hate the eternity part. All right, so let's repeat. M41, M46, M47.
It's still...
No, it's up.
Oh, it's up.
It's up. Just we're lagging. Okay, then we went up to M38, M36, M37. Magnitudes 6.4, 6.0, 6.0, and 5.6. So we're going down 6.0, 6.4, 6.0, and 5.6. Distance, all about 4,500 light years. You're good there. M35, right off the tail of Castor. M35 had that secondary that had that other open cluster that was 16,000 light years, but M35 itself is 3,000 light years. It's magnitude 5. We then went to your extra credit. Step outside, take a video. Naked eye if you don't have a telescope. If you don't have binoculars, naked eye, go out there. Take a video of you saying, "Hi, I'm so-and-so. I can see it. It's beautiful. It looks like whatever." So that's M44. Remember, it's really close. M44's brightness is 600 light years. One of the closer open clusters. And then M67 is the old one. Its magnitude is 6.1 and it's 2,600 light years. Okay, I'm answering questions because the next stuff gets good.
Do you want me to eat more?
No, but you might need to get some if you need to take a break. Okay, guys. With our time, we're going to go over to Leo. Then we're going to go up to Ursa Major. We'll try and hit some here. And then lastly, I want to end up with the Comet Atlas Y4 2019 and show you what it looks like right now. Wow, that looks good. So let's go and see. We are now leaving the actual edge of our galaxy, and we're going to look to the side, like looking out. If you're in a pancake and it was puffy in the middle, we're not looking to the edge. We're looking out beyond, out into the frying pan or beyond. So we're now going out here. All right. Away we go. Going to go up to Leo. Let's go to M95, M96. Looks like 3 of them. Let's get 3 of them right in one way. All right. Yeah, this is a real night lab. We're killing ourselves. We're down to 3 viewers. Okay.
68, actually.
That's less than last time. All right, it's still going. What are we doing? We're following the telescope as it moves closer and closer to Leo. We're going to the back foot of Leo. The front of the back feet. Okay. Let's center it a little bit. So it's missing a leg, but right here, we've got our first set of what are these Messier numbers? All right. I'm going to up the ante. I am going to take the grouping and I am going to kill this. What am I trying to say? I'm actually going to up the exposure rate. We're going to go up to 30 seconds instead of 15. Okay. First group, M95, 96, 97. Let's see what we got. We're looking beyond our galaxy. We have to wait 30 seconds. Okay. Telescope's pointing somewhere else. You can see it over the corner. You guys, wow, it's like I became a hard-nosed teacher. Here we are. Whoa. What? Look at this. So this is M96. Look at this. This is beyond. Look at this. Look at that galaxy. This is a barred spiral galaxy. See that bar? Beautiful. Beautiful. This is just insane. All right. So here is M96, 41 million light years away. It's magnitude 9.7, and it's being distorted because of another one. Let's look at M95. Oh, that is 95. Let's go to M96. So we're going to go to M96. Take a look at this. So we're going to go right close by. It's slewing over. Just moved right next to it. So if you're going to draw this, it's front foot. We can look at that a little bit. Okay. We're going to go ahead and take a 30-second image. Remember what this is? We got this beautiful M95. Let's take a look at M96. That's insane. So we're going to take another 30 seconds, see what we got. And actually, so both are spirals, but you can see that bar. I swear that was M96. It's got that barred spiral. All right. We got 6 more seconds to go. Cooking away. Oh, my word. So we're looking 41 million light years away. Wow. And the next one pops up. It looks similar. Look at this. Wonder if I can go back and at all. All right. I'm just trying to see if I can go back in. It's not letting me do it. I guess it doesn't let me do it. All right, so here it is. This one, the other one was M95. This is 96. A regular spiral galaxy, magnitude 9.3, 41 million light years away. These are all interacting. Let's take a close peek at this. I think we'll just cover those two for now, and go to the down in here. Let's go to the even more impressive. So we're starting to see galaxies at 41 million light years away. 41 million. We're looking at galaxies live. I mean, look at that. That's pretty beautiful. That's 100%. Again, if I bring it down in size, oh, look at these. They're the other. Look at the group. Upper left-hand corner. I don't know if you can see it there, but so here's an M96, and look at some more over here that are interacting. Oh, I know what these are. Oh, anyway, beautiful. Let's go in Leo and look for some more stuff. Let's amp this up and make this more exciting. M95, M96, and we'll answer some more questions in a moment. Oh, never mind. We're moving along, or people just give it a enter. All right, slewing over to M95, 65 and 66. This is called the Leo triplet. Wait till you see this. I'm going to go ahead and get the cranking going on and talk a little bit more about it. All right, we just moved over here, and we're going to get SGP to work on it. We're at the hindquarters of Leo, and the Leo triplet is pretty spectacular. They're both 8.9 or 9.0. These are a little closer than 95 and 96. 95 and 96 were 41 million miles. These are about 35 million miles. There's 3 of them. And as it downloads, let's take a peek at this. Oh no, that is outstanding. Holy cow. So look at these. These are just totally amazing. So what do we got? We got M66, M65, and the Hamburger Galaxy. They're being torn apart by the gravitational pull of each other. Let's get over here. Look at those. You see these for real, live, action. Maybe too big word. Oh, there they are. All 3 in this 30-second exposures. Look at the spiral nature of this galaxy. Look at this one. So this one is being distorted more. These are, the distance. Oh, I love this. The distance between 65 and 66, and you can take one snippet picture here and get them all in one, is 200,000 light years. Now we've been throwing about numbers all night, but our galaxy is 100,000 light years distance. So if we put the Milky Way, it would expand half the distance. What? 200,000 light years. Our Milky Way is 100,000. So you start to see how big these are. The Hamburger Galaxy isn't even a Messier object, but look at the dust in here. Look at the distortion. I mean, you can see the tidal pull of each. Oh, gorgeous. All right. Any questions? I think that we need to take that kind of desktop break. I mean, I'm looking at, I'm amazed. I look at this and I say, this is live, the universe and beyond. And 30 seconds to a decent This is observatory stuff, Mom. Niece. Okay, questions?
What star's your favorite?
What?
What's your favorite star?
I like the hamburger galaxy. It's not even a Messier object. Look at that. Look at that funky looking the edge on galaxy like ours. So notice the hamburger galaxy is about the size of our Milky Way. It would go half the distance. And 65 and 66 are a little different. Okay.
So you don't have a favorite star?
Galaxy. They're galaxies.
You don't have a favorite star?
I don't. Okay, next. We'll keep on going. It's getting better. We got a question?
I got one.
Okay.
What are the specs for the M66 and M65?
Good questions. All right. So M65 is 9.2 magnitude. M66 is 8.9 magnitude. The distances from us is 35, 37 million light years. Either you're going to be fine.
And then, are we doing M97?
Yes. Who asked that?
Terry Wang.
Terry, you know about M97? We're going there.
And
2 points. I got to write that down.
Ben Hagee says hi.
Ben, didn't he fail my class? No, that was his brother. That was Jack. Love those guys. Love you, Ben. Love you, Jack. Okay, Terry Wang, 2 points. Someone else got points earlier too. I don't remember. Oh, I wish I remember. Okay, let's move on. Now it's getting good. We're seeing galaxies for real at a remote site like someone's backyard. All right, where are we going? Let's go to Ursa Major. I like Ursa Major. All right, we're going to go up to the top of Ursa Major right here, making sure you guys can see it. So we're going up here. Go ahead. We're going to go to something called M81, M82. Remember, Messier's objects were the ones that would get in the way of his occupation. I'd love to have an occupation instead of Dan Bartlett, teacher. I'd love to have it. Dan Bartlett, comet hunter. Oh yeah. Imagine I go to my favorite eating spot, Nina.
What?
I go to my favorite eating spot. I go,
What?
hi, Dan Bartlett, comet hunter. And then they would say, thank you, sir. Would you like a Big Mac or fries or cheese? Oh, what are we doing? The telescope is on its way. It's moving.
You want me to get you more Mountain Dew?
Oh, you'd be great if you did.
You want it? Wait, here.
Okay, that telescope is moving. Do you see it moving? Let me just, quick.
Oh, let's get you ice cubes. You're shaking like a bird.
So it just moved over to a different part of the sky. That's cool. We are right here. Let's zoom in for you. I'm going to zoom into M81, top of Ursa Major. Okay. Zoom in. I told you I would. Let's center on it first. There it is. Zoom in on this area. Where are we at? Oh, we're getting close to the Big Dipper. M81, M82, 30-second exposures. And here we go. Wait for this. Remember, it's taking its sweet time. That's what it's doing. Woo! These are beautiful. My gosh, look at M81. Look at this, M82. Oh, you know what? We have just scored. I thought 65 and 66 were good, but look at this. 30-second exposure in someone's backyard. There's M81. Oh, if you've ever heard of the term grand spiral, well, there it is. This is a spiral galaxy, M81. It is the second. It is pretty crazy. It is. Well, I got tons of notes. It's called Bode's Galaxy. Over here is M82. They are interacting. In fact, 100 million years ago, these were closer, and it caused this galaxy, M82, the cigar galaxy, to go through a rapid expansion explosion. So let's go ahead and turn this down a little bit. You can see all that roughness. This is insane. That is showing the star birthing region in there. I'll give you numbers in a moment, folks. I'm just looking at it. And we're getting this spiral. Oh, too much. Let me do it auto. Well, that might be good. All right. So there it is. This is showing some just beautifulness. We'll get back to the location. I know some of you guys are looking for that. But M81 called Bode's Galaxy, 6.1. I've seen them in binoculars. Is the magnitude. The distance is not too far away. It's about 12 million light years away. Thank you, Niece.
Yeah.
About 12 million light years away. The Cigar Galaxy M82 to the right is also about, it's the same distance away, 12 million light years away. Remember, this group is actually quite close. It's the second nearest galaxy group, new, then to our local group, with Andromeda, M33 and us. This is the second closest group. So I can't believe it. This is all being disturbed and causing the star birthing because 100 billion years ago, this thing was close enough to rip it off. This is actually being distorted. What a great grand treat this is. What else can I say? Oh, the distance between the two is the distance of our galaxy plus about 30,000 light years. So it's about 130,000 light years difference. The Milky Way would fit in there with a little bit of spare. Amazing. Okay, so let's go on out a little bit. You guys did some snipping.
Real quick, Victoria, what is M97's magnitude and distance?
We haven't got to M97. That was Terry's Wang's.
I just got a drink. I have no idea what time.
We haven't done. So what do we got? Magnitude and distance for M. We haven't talked about 97. We've already talked about 81 and 82. And 81 was a magnitude of 6.1, and the Cigar Galaxy 82 was magnitude of 8, and both are 12 million light years away. All right, what next? Terry asked, what about 97? Let's go to M97. Where are we going? I will show you. We'll let the stuff go. Let's take a look at M97. Why does he want M97 so much? I don't know. Let's take a look. M97, we're going to go over here. Oh, get a little bit smaller. Oh, we have to go around the world. So we just hit M81, M82 right here. We're now going right here to M97, M108. I'm looking at the time, guys. We'll get a couple more, and then I want to get the comment, and then we'll just make it easy. So I don't want to stress you guys out as I feel like I'm not used to talking like this either. All right, so we're going to take our pictures. This is where M97 is. I don't want those. We'll take our 30-second video. We're right here. And why does he want 97? Because M97 is the Owl Nebula. And the Owl Nebula is only about 3,000 light years away, magnitude 9. And it's next to another galaxy, which is called M108. So what are we doing? We're waiting for SGP to load up. Do you see the bar to the right? To the right. And we're going to get our exposure. We're getting close to the end because I think we're going to do about 10 more minutes. There it is. Oh. Whoa. Okay. Planetary nebula. There it is. Ooh, stars are sagging a little bit. I'm going to go ahead and take another exposure. I don't know why we have drift right there. We shouldn't have drift. But anyway, there it is. It's called the Owl Nebula. The star in the middle is cooking it away. It's so hot, it's causing the expansion of gas to glow. It's got these two dark spots, makes it called the Owl Nebula. Magnitude 9. I've seen other limits of magnitudes of less than that. This thing is 3,000 light years away. It's about the size in our sky as we see it, about the size of Jupiter. It's a planetary nebula. It's the end product of stars. Yeah, so there, the stars got a little bit better. Did you remember there's another thing in here? M108 is off to this side down here. So here we got something 3,000 light years away. Here we've got a galaxy over here. Let's get closer to it. Called M108. I think I got 2 more for you to do. 2 more after this. I'd like to do a lot more, maybe 3. Oh, we're losing time. All right, so maybe 3 more and that'll do it. So this is M108. It's a barred spiral, 10th magnitude, 32 million light years away. So you can see M41 is super far away. 32 million light years away. 32 million light years away. And here, 3,000 light years away. All right, M97, M108. Okay, where next? Getting to the end. I want to go to one of the stars. This is near the pointers. Remember our pointer stars? This was the bottom one called Mira. If we go SkyX right here, we're now going to move over to the other star and see M106. M106 is near the other pointer star, which is Ficta. So let's go to M106. I'm sorry, M109. We're getting close to the end. I know it's 9:30. I want to get the comet. I want to answer questions. I want it to be great. Hang in there, Nina's. She's having a hard time. I'm having a hard time because I know that, I don't know, this is, to me, it's beautiful. But for you guys, you know, who have not been treated well, there we go. Notice the location, M109. We are going to go ahead and crank up a 30-second exposure of it. And Nina, you can ask me some questions as we do this.
Yeah. Do you know the M108 magnitude?
Yeah, M108 magnitude was, again, about 10th magnitude. 10th magnitude for 108 and 9th magnitude for M97, the Owl Nebula.
This chair's broken.
Okay, will you sit on it? Funny, you know, Sean broke it.
Sean
broke the chair. You just got to kind of hang with it.
Jesus.
Yeah, I'm
There
sorry.
you go.
Yeah, oh, they're old. Okay, so where are we at? We broke a chair. Whoa! Oh, there. This is beautiful. Look at this. First of all, there's Ficta. That is that star in. Let me show you. Let's go back. So that bottom star, where you see where the yellow pointer is, that's Ficta. So this is Dubé, and this is Mirac. This is Ficta, and this is Megrez. Is Alioth, Miser, and Alcate. So we're right here. But look what we got. So M109 near Ficta is a bar spiral 9.6, 84 million light years away. It is unbelievable. But let's get closer. You guys, live. Did I say it's probably the furthest thing away that we're going to see tonight? 84 million light years away. Look at the bar that goes across. Central nucleus. There's other galaxies all around. It's supposed to be its own group.
So I got more questions when you're ready.
Okay, more questions as I set up.
Okay, M81 and M82 magnitude and distance.
Okay, 81 was 6.1. M82 was 8.0. Both were 12 million light years away.
Terry Wayne, can we do an overall review of the different stars / galaxies and also the overall process of things to do?
Yes, at the end of the evening.
Okay.
Yeah, we'll do a review at the end because that's a bad teacher if I didn't do it.
And then the distance for M108.
Distance 108.
Yeah.
Oh, that was 33 million light years away. 33 million, 32 million light years away. All right, we're going. Two more. Let's go M101. We're going to go to the no star Alcade. I know you got more questions.
No, it just says it's not zoomed into the live picture.
What do you mean?
I don't know.
We were zoomed in?
I don't know.
I did.
Okay.
I did. I zoomed back out and went somewhere else. Going to have to play that one back. All right, we're going to go to the no star, and we're going to go to M101. And there's so many more guys, but you're seeing the real life stuff. I don't know if you've, I think you're, okay, we're going to watch this, do a little slewing. Okay, right off the nose or the tail of booties in the constellation of Canis Venatici. No, it's still Ursa Major. I'm going to center it. I'll zoom you in there. Center. Why isn't that centering? All right.
M97 magnitude?
At 9. That's the third time I said it. People aren't listening. I need to fail someone. All right. So we are at M101. 2 left. We're going to go ahead and take our pictures. So right now, M101 is called the Pinwheel Galaxy. Spiral galaxy, 7.8 magnitude. Let's get a picture of it. Right now, nothing's there. So we've got Remember, that's M109. We're at M101, the 101st out of 103 objects that were listed in 1784 Messier. It's cranking away. You can't tell right now, but it is. You look at the green lines, it's going across, and Shazam. Whoa. Woo! Okay. That is gorgeous. Look at this. And there's another galaxy here. So M101, Pinwheel Galaxy. Magnitude 7.8. Could be seen in dark skies with binoculars. Distance 27 million light years. 27. Large. Larger than our galaxy. Our galaxy is about 100,000 light years across. This is 170. Remember, 27 million light years distance. You can see as you get closer the star birthing hydrogen alpha areas, the nucleus, the pinwheel. It's got one of those, this grand spiral sizes. Oh my word, that is gorgeous. Look, make it different brightnesses. Oh, that's incredible. Whoa, whoa, whoa. Folks, you're seeing this really live. Oh, albeit it's 23 million years ago that it came over. All right, you guys, one last one. This is also, we're going to move, this is above Alcade. We're going to go below Alcade, show you where we're at. And then we could do any kind of review that you'd like. We're going to go back here. We're going to go below it. So we're the nose of the big beer. We're going to now go below it to M51. I'm surprised nobody said, hey, Mr. Bartlett, what about M51? So we'll go ahead and find that that beautiful galaxy. I'm going to watch this thing move. Move. It's slewing ever so slowly. You might see it in the bottom corner. It's going to move over just a little bit and finally it gets there. I'll start taking my pictures, although you don't know that I'm doing that right now. I'm doing a little tricky thing. You guys, I'm not a big professional, not at this. But, to go out and actually look in dark skies with a reasonably small telescope and look at this. We're going to look at M51. This is the Whirlpool Galaxy. All right.
While you're setting up, M101 magnitude.
M101 was 7.8. All right. Here it is, folks. Last one of the evening before we go to the Comet. And we're going to look at this. I can't wait. Oh, no, that can't be real. That's gorgeous.
That looks like something's going to happen, though.
Yeah, well, this one was one of the first seen to, two people saw it and they said that it was interacting. It's the two interacting galaxies. They're kind of going against each other. Let's pull out. I overexposed it. You can see all the nebulosity. Those are actually stars. And you can see the spiral design.
It's sucking it.
Yeah, one's interacting with the other. The Whirlpool Galaxy. That's out there now. This is in the constellation of Canis Venatici.
Is that still?
Right.
Because we're seeing it.
We're seeing it. Oh, good question. We're seeing it 23 million years ago.
What is it still?
No.
It's gone.
Well, no, it's still there. We got to remember, it takes us about 200 million years.
But I mean, in 200, in the, what is it?
We're seeing it 23 million years ago.
Okay, but currently, would it be gone because of the interacting?
No, it would be slightly, if it takes us 250 million years to go around our galaxy, in 23 million years, it would move, but it wouldn't be totally gone.
Okay.
So it is magnitude 7.9, 23 million light years. Fantastic. I'm going to go over some stuff. You guys are snipping this. And let's do a grand review. Start coming up with your questions, guys, because I want to get that comet. I want to get in there and show you Comet Atlas Y4. Let's do that. And I want to slew there.
What galaxy is that?
That's M51. All right. So we're nearing the end of the evening. I don't know. I think I've had too much grand expectations for you.
The specs for M95, 96, 97.
I'm going to work it. Let's go back to the beginning galaxies and work our way forward. We'll do that in a moment. At the same time, I want to get something cool here. We got some more things to go over, folks. So let's go over and do a quick review, and then I can do some talking here. Okay. Now, location, you're going to have to go back and watch this thing. But, all right, so we just saw M51. I'm going to work back. We're going to go to the last one and backwards. So let's give you some numbers that you need. Okay, M51.
I'll tell you, because Jenna says she's 30 minutes behind, but she says this is beautiful.
Jenna, give her, Jenna, was it Jenna Wang?
Jenna Wang.
Jenna Wang, 2 extra points because I needed that. Because I think it's beautiful too, but I feel like being with you and talking to myself, it's kind of crazy.
Well, no,
So,
I'm getting compliments.
Okay, but it's still tough because you don't get the feedback of like, my gosh, look at this. That's M51. Oh. Okay, we got a new frame coming out in a moment, but all right, you need numbers. Everybody, get your pen and paper ready. We are going to start with M51, work backwards. All the things you need for your photo album, and you don't know what I just got. No, stop. Get that stuff ready. Take a look what I just got. You see it? That's insanity right there. That's a breaking up comet. Okay, but there's a problem. Do you want to see why it's overglowing? The camera that takes a picture of the telescope is shining infrared radiation at the sensor, so it's blowing it out.
Oh.
So I need to move that. See, guys? I'm going to move. I'm going to move. You guys give me a moment. I'm going to move the telescope. See where it is? So you can watch it move as I move it. I'm going to move this thing.
Yeah, so while you're moving it, Jack says, yeah, this is super cool. And Blue says, it's not crazy. This is amazing.
Blue. Oh, Blue. I didn't know she's alive. Blue, 2 points.
She's been talking the whole time.
But I didn't know. Blue did 2 points. All right. Okay.
Jack says, I made M51 my home screen.
Jack who?
Jack Lewis.
Jack, 2 points. Making it home straight. Okay, we're moving the telescope. We need to go and point it at the lake. What? We have a lake? Yeah, okay, we do. Because it's interrupting our sensor. Goodbye. All right. That's looking at the lake. I'm just looking. Oh, okay. We're at someone's house. I don't know where this is. It's bothersome. All right, now I'm going to take another picture. Okay, because we have a comet to look at.
Vicky says hi.
Vicky! Hey up! You guys! We need to be back in class. This is not the way to do it. I feel so isolated. A loner, and I'm a loner anyway. All right, where are we going? Oh, not there.
What the hell's the
Not there.
sound?
Not there. Oh, that's trippy though.
What's this beeping sound?
Oh, that means there's motion detector. So if you guys are hearing a beeping, it's motion detector. Okay, let's do a quick review while this thing amps up for a comet. All right, M51, ready? Here's what you need. This is your photo album. You got a picture of M51, you snip it, and you need M51. It'd be nice to put down the Whirlpool Galaxy, but you don't need it. It is a spiral galaxy. Magnitude 7.9. Distance 23 light years. Backing up. M101. The pinwheel. Remember, it was twice the size of our galaxy. Its brightness is 7.8. It's another galaxy. 27 million light years. By the star Ficta. I hope I said that right. Nina, you should make those drinking sounds. This is Mountain Dew, guys. Yahoo! I may never go to bed tonight. All right. So, what did I do here? I was at M101 Pinwheel Galaxy 7.8, distance 27 light years. By Ficta, M109 was at Bard Spiral, magnitude 9.6, 84 million light years. 84. That age of dinosaurs. Yeah. Then we had N97, the Owl Nebula, planetary nebula. Brightness of 9.0, distance 3,000 light years. We had 108 next to it. It was kind of that gross looking spiral. 10th magnitude. An idea of 10th magnitude is binoculars is about 9th magnitude. So 10th magnitude, you need a telescope. 32 million light years away. We had M81, M82. M81, Bode's galaxy, that beautiful grand spiral going around it, magnitude 6.1. Could see in binos. I've seen it easily in binos. Beautiful. 12 million light years. Interacting with the cigar galaxy M82. Magnitude 8. Also 12 million light years. You saw the distance? You could get the Earth. You get the Milky Way in between it. That's the distance between them. A little bit more. Before that was M65, 66. With the Hamburger galaxy, my favorite. 65 was 9.2. 66 was 8.9. If you got them mixed up, it's okay. They're both about 35, 36 million light years away. And we started the galaxies with 95 and M96 at the beginning. M95 was that barred spiral at the beginning, 9.7 magnitude. And 96 was the other galaxy, 9.3 magnitude, a little bit brighter, both 41 million light years away. Okay, as we get to the very end, look at this galaxy, look at this comet. You got to see this comet. This is, and I got some real pictures, folks. So let me show you the comet. Okay, there it is. Look at this. This is full scale. This is Comet 2019 Y4 Atlas. You may have seen a video of two of mine. It's breaking up. You can see the nucleus. Oh gosh, it's gorgeous. Isn't that nice? That's right now, that comet. And let me give you a little bit more information. It's really a colorful comet. I need to stack it all night long. Here's last night. I want to show when I stacked last night's images. So we're into this again. Remember this? Okay, let's go last night's. Okay, here we go. Oh, no, that's not where it was. Where was it? I'll find it. Give me a moment. If you want to sign off, I get you, but I got to show you these pictures. They're amazing, actually. Videos. Where did I put it? F. That's right. Here. Nope. Oh, I hate when I get stupid here. Where did I put them? Oh, it'll come to me later. You know how that works. I know it was here. Okay, let me go off. Better yet. Watch this, guys. This is putting all the images to go a week ago. Look at that. This is, okay, wait. You saw it. Wait. If I took all of this and captured all night long and stacked them on top of each other, I get this. So I took this and I put this on AstroBend. Isn't it gorgeous? Look at this blue-green halo. That's the atmosphere. This cyanide and diatomic carbon stuff with some dust tail right there. And then I decided to process it more, and look what I got. I got these. These show the nucleus at different stages, and look at the different breakups, like pea pods right here. Almost done, folks. I know, we're past time. No, we're not. We got a minute. Notice what I won for this. I won, hold on. I won an award. Top pick. Woo! I got a top pick award for these. So people like it. And last, right now, this is where it's located. So let's blow it up for you guys. This comet is about the distance we are from the sun. We are that distance from the comet. So the comet's right here. We are right here. And the comet's here. May, it'll be closest to us. And then end of May, it'll go around the sun. Let's run this forward and watch this as we go. I don't know if I can get that closer. Okay. Yes. Okay. I'm going to play it forward. Everything's moving. Earth is down here. Here's the comet. Look at this. This is how it's going to go. And right about there, it crosses and gets as close to the sun as possible. It's probably going to all burn up because it's falling apart. Beautiful. Anyway, you guys, I know it was rough for me, probably more for you guys to get it going. I will put the information on Canvas. You guys will figure out how to do it. You've got this already done, hopefully tonight. you've already put your M41, you put your M46 and 7, then we went up to M38, 36, 37, and 35. M44 is your extra credit, the Beehive, and M67, that old one that's outside of the plane of our galaxy. Remember, these you could see with your binoculars. This is what you're seeing in there. These these open clusters are all being formed from clouds of gas like we were once formed. Then we moved to Leo and saw 95 and 96, and then towards the the Leo triplet in the hind feet of Leo, and we saw the Hamburger Galaxy. We then went up and saw Bode's Galaxy, Cigar Galaxy up here. We went to 97 and 108. We did that one that was 80 million light years away, M109. We did M101, and then which is the Pinwheel Galaxy, and then we did the Whirlpool. So that's what we did. We need to have a talk to whether we want to do this again, because we have a bunch of things to do. We've got some math left to do in class. We've got to finish the constellation test. And I would love to do just a thing on galaxies. And you guys, I didn't even do the real cool things, M3 and M53. Have to be another time if you want to do this. So I need to get a lot of people saying, yeah, now I know what we're doing. Let's do the same thing next time, and get credit for it and review it. So let's ask any final questions before we say goodnight. All right, niece.
All right. Here we go. So.
Questions?
This is not a question. This is the first things first.
Oh no.
Ansley says, "What am I supposed to do when this is bored? I'm so bored." And then Blue says, "Nina, when you can, please tell him this. Mr. Bartlett, thank you so much for this. I was seriously looking forward to this, and it really makes my day to see you and hear you talk. I miss your passion." And Ansley says, "This was so fun, and it's already almost over." Blue says, "I'm tearing up."
No, we're not done. If we want to do this, we can do some more of this. I'd love to do more of this.
Ansley says, "Tell him I miss him so much, and they always made my day." Blue, you made me emo. Mr. B, and then Francesca says, "Mr. B is my favorite person of all time. Sorry, everyone else."
I'm
Blue,
famous.
Actually tearing up.
No, you guys, you know what? Think for a moment more than let's get nerd, okay? Forget about what's going on. We just looked beyond our, because I'm out in the mountains right now. We just looked at the thinnest part of our space into the hearts of our galaxy with clusters being born. And then we looked sideways into the depths of emptiness. And we came upon these spirals that had billions of stars like us. And they're everywhere. And I mean, we're beyond just what we're going through in every one of our houses, in every one of our constant worries. And back to you guys, I have two things to say. Number one, I don't know anybody who's going to endure more hardship than you seniors have ever endured since World War II. Because a lot of those folks just signed up and left. You guys have got a game changer, and you're going to be telling this stuff and what you've gone through, not what we saw tonight, but you're going to be telling your grandkids what we did and how we did it at the beginning. Hopefully we'll never do this again, but we don't know. And hopefully we're doing it right. I will be done with this remote location with Nina. We're coming back on Sunday. We'll be back in the area, and hopefully I know the water's warm. Hopefully they'll let us at least at the beach. They got to let us at the beach. And then I'm going to come back in May where the galaxies and the comets will be brighter and doing some funky things. You guys, I really don't know how to talk to a camera. I want to apologize for that. I love talking to you guys, feeling you guys bothering me bothering you. I like that. I love the interactions. I am renegade with my daughter. Thank God she's here to help me, because I need to hear you guys and hear your voices, because nobody likes to live like this. Okay.
So, we got...
All right, last questions?
No, just Jack says, "Thank you for this. It's been a real fun time." Grace Hagee says, "Thank you for this, Mr. B."
You guys.
Rachel Rosen,
thank you all.
Mr. B, miss you. Grace says, "You're the smartest person I know." Nathan Toomey, "Thank you, Mr. Bartlett." Francesca, "You're the reason why I'm majoring in astronomy."
Yes, Francesca. Oh, that's 2 points.
I love you, thank you, Mr. Bartlett. Alex Forito, Thank you, Mr. Bartlett.
Yay!
Ola Joe, thank you for the great night lab. Grace, you thanks you. Oh, you're welcome, Grace.
And I love all you guys. This will be served. Remember, take pictures of yourself looking at the beehive, and then let me know if I can use that for further productions. All right, all you guys, with lots of love. Nina, get your face in here. I need you with your earphones. Come over. Come here. Come here. Say goodbye.
Okay, you should read these really quick.
Oh, I got to read more?
Blue says, you're doing so well, Mr. Bartlett. You've been doing a great job.
Thank you, Blue.
And then she says, a group Zoom call. Joey Colgan, thanks, Mr. B. Miss you.
Yay, Joey.
Visit class next year. Kendall, David.
Ooh, you better.
David?
You better.
Thank you. That was a cool
Kiki.
lab.
Kiki. Yay.
Gifted to me. Where do we turn the photo album of the labeled screenshot?
That's not due till next week. You guys, all deadlines. You don't have any assignments until after Tuesday in Astro. After Tuesday, we will start talking about when this is due. Don't even think about it. Enjoy the next few days. I will put the instructions and deadlines. It won't be due until the end of next week. Thank you, Nathan.
I got Colin. Thank you, Mr. B. You missed my 2 points.
Okay, Colin and Nathan, I'm going to give him 2 points too.
I got Terry Wayne. Thank you, Mr. Bartlett. You'll always be by far my favorite science teacher.
Well, you have short-term memory loss. You've been hitting the head a few times. All right, Nathan Toomey, Nathan, Colin, 2 points. All right, you guys.
Mia says thank you so much.
Mia.
Ashley Sorrells, miss you, Mr. B.
Oh, I miss all you guys. Yeah. Okay. Anyway, I guess say goodbye to live streaming.
I'm almost gonna fall.
Oh, come on over.
Oh, okay.